What is up, everyone? Another day, another Leetcode. So we have this right here, this problem called same tree. Given the roots of two binary trees P and Q, write a function to check if they are the same or not. Okay. Two binary trees are considered the same if they are structurally identical and their nodes have the same value. Okay. The number of nodes of both trees equals 0 to 100. Okay. So what I'm going to do here is this. Okay, so what this tells me, let's look at the output first too. So basically you're spitting out two arrays. And you want to see if they're the same. So what I can do is this. I can do in-order traversal. So if you've seen my in-order traversal video, you can go back to that. I'm going to do an in-order traversal of both trees. So what that means is it's going to give me the exact order. And if the trees are the same, you should have the exact same array output. So once I have two arrays, I can then compare those two arrays by first checking the length and seeing if I even need to go far enough to check that, right? So I check the length of both arrays. If the arrays aren't the same length, then I can just end there. They're not the same. If they are the same length, I can just compare the elements and they should be in the exact same order because they're in order. So in-order traversals go left subtree, root node, right subtree, right? So if we're following that logic, everything in that order should be the exact same. That's why it's called in order. You know what I'm saying? So let's do that. So let's create a function. So I'm gonna use recursion because we're comfortable with that. So first, stores 1. So I'm going to create two empty arrays. These are going to be my outputs. Stores 1, stores 2. And we have our P and Q root nodes, so it's going to be the exact same as my old problem. All I'm doing is creating two sets of arrays to compare instead of the one set. The last problem was sort the thing in order. So sort the thing in order, return the array, right? So now I'm doing the exact same thing. I'm sorting the thing in order, returning the exact array, and I'm doing it twice, basically. So that way I could compare if both trees are the same. So let's take a look. So return, and then it's either going to be true or false. So right now for now I'll put false, or I'll put true. And then while I'm comparing the two arrays, that's when I'll check for whether they're false. Because if there's even a single case where it's not true, then I could just return false. Otherwise, it will return true. So that's my base case at the end, return true. Now I'm going to create my in-order traversal function. So I'm going to go def in order trav, and then it'll take a node and it'll take an array. It's no curly brackets because it's Python. Okay, so now that I have my node and array, I have to traverse it. So what is going to happen here? So it's going to go through fifth node left, in order trav node dot left feed the array in. And then so I go 1, 2, 1. So now I gotta add the node. So array.append node.val. Because if we look at the top of the properties, this is the properties for the node. This stuff that we don't touch. So it's gonna be definite node val 0 left right. So they're creating a generic node and filling it with a value and then attaching it to a tree. So it has the value, it's left node and right node. So the left and right are both pointers to the next node, which could be null as well. So if node left. So if node left, this is basically saying if node is not null. It's just a faster way of doing that. Then I could put in order trav node.writes are. So I'll spit out my array, and then I will the memory is going to be right here. So I don't have to return anything. All it's doing is traversing till the end. In order trav, if node left, and trav, if node left, 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 left. Okay, so I'll go if boom. So now I gotta call this function twice. So let's say in order trav, then I put in my node. It's gonna be p. And I'll put that in stores 1. That's going to be the array that I'm going to store all my traversals in. And I'll call it again. In order trav. And then this is going to be q. I'm going to put that in stores 2. So basically what I'm doing is I have to take the memory. So right now, whenever you do an order traversal or any sort of recursive iteration, when you recall a function, it refreshes the call stack for that function. So your call stack will fill up with calls, but your function does not retain memory. So for example, if I have an empty array here and I call it within this function without creating a separate function, it's going to refresh the array and go back to 0, this empty array again every time. So what I'm doing is I'm taking the array and I'm feeding it to a separate function. So every time it calls, it's calling the same array. So it's feeding the array in a separate function for the same traversal. So that's why this just does its own thing and feeds this other array. So boom, I'm doing shit here, feed it, feed it, feed it. Rather than if I had it all here, it's going to refresh. You know what I'm saying? That's why I don't retain any memory here. I don't return anything, nothing. I'm just straight up adding values to the array that's in another place. And now when I get back to the original function, it fills up this array, just like we did in the regular traversal. So now we just compare. So if for I in range, or no, I could just go for item in stores. No, I gotta do for I in range. For I in range. Now first, let me do a base case. If len stores is not equal to, so if len stores 1 is not equal to the len of stores 2, then return false. Because if they're not the same length, they're not the same, right? So that's a quick check. So if they are the same, then I need to check element by element to see if they're in the correct order. So that will take O of n time, because I have to go through each element of both arrays, which would be O of 2n technically, but if we go big O, it reduces that factor down to O of n. So if I go to range, then I go stores. Let's see. So go range 0 to length of stores 1. So right now, if it passes this, we can assume safely that they are the same length. So if stores 1 I is not equal to stores 2 at I, return false. That's my other base case. Oh yeah, it's got to be capital. No, it's got to be capital. Boom. So basically, if it's not the same length, return false right away. We're done. If it is the same length, check each element at their corresponding order in the array to see if the tree follows the same structure. And if that's not the case, then we know right away we can return false if the indexes don't match. So if it does pass all this, then return true because it matches. Same length, same order. Right, so let us give this a try. What? If node left. Do I need a base case? Oh yeah, I need my base case. So if node left, and then if node equals none, because I need something to return. I need a base case to tell it to go backwards. So if node equals none, return. Let's try that now. Boom, accepted. So let us try and submit that, and I will do a quick overview. Wrong answer. No, okay. Okay, so if node equals none, I'm going to say this. I'm just going to append it. So array let's see if that fixes it. Array.append null. Because here's my test case, so it just shows 1 1. Usually we don't add nulls to the array, but in this case it does. So what I want to do here is figure out where the null is and add it to the array. Let's see, so append null. I like spacing out my code because it's like I like seeing it in chunks, so it's like easy to. So array.append null. Okay, this should fix the issue. Oh, because we don't put null. There's no such thing as null in Python. It's none. Array.append none. There. That makes sense now. Okay. I keep saying null. See, like when I see this, it's like some JavaScript like habit that I have. Let's try submitting it now. Null. Okay, so true. I'll put true, false. Five for 1, 4 4. It returned true. How could it return true though? If the lengths aren't the same. null null for null 1. So that should PQ stores 1, stores 2, len stores 2, stores 2 I, stores 1 I, oh, okay, so maybe it's because I'm not iterating through, it's iterating through the first one, right? So if the first one's smaller than the second one, that's just going to assume they're the same length. So that's what's going on here. But the thing is, if they're not the same length, so check length array in Python. Let's check that. Len. So that should rectify the issue here. The other thing is 541,514. This should have ended right there. So output is true. Why would it return true? What's the other thing? Maybe it's some sort of bug? Let's see if we're going by that logic. 1 2 3. Okay, let's check test case 2. 1 2 1 2 null. Okay, let's check test case 3. 1 2 1 1 1 2. So look right here, if it doesn't match, look, I don't see how it could return true. 4I in range len stores 1. This shouldn't even pass here if it's false. Let's see. Array.append none. If node equals none, array.append none. In order trav. Right. It should be the same if we're following the same order. So stores 1, stores 2, stores 1, stores I, stores 2, stores I, return false. If it's not equal, return false. If the lengths aren't the same of stores 1 and stores 2, I'm just curious, what happens if I do this? Does that still pass? Is that why? Yeah, it still passes. So for some reason, it's not checking this. What if I move it? What if I move the statement? Okay. Oh, because it starts traversing before, so you want it to filter out test cases. So this is doing its job. See how less test cases pass when you move the statement? It's because more filtered through the length category. It's supposed to take care of the length stuff here. For some reason, it's not doing that. Array.append node val in order trav node.write array in order trav. Run. It's literally not passing the last test case, which makes no sense. They don't even match elements here. Expected false, my output is true. Why is my output true? if I go the maximum between the two lengths? But it shouldn't matter, right? Because it should already go false as soon as this isn't true. So 5 and 5, 1 and 4. I'd have to see my outputs. Why is this not working? Why is this not working? It doesn't support visualization. Okay, let's plug in the ChatGPT. Let's see what's going on. ChatGPT. My code. No, failing test case. My code. Failing test case. My code. Let's go here. Hi. Maybe I'm missing something obvious. Your current approach may not accurately compare the structure of the node value of two trees, as it only compares order value nodes without considering the positions of the tree. For example, two different trees have the same in-order traversal with different results. You should directly compare each node and its children in a recursive manner. Okay. Okay. Is same tree. If P and not Q, return true. If one of these nodes is null and the other is not, so it's not P and not Q. If values are different. It's weird how it goes through all these test cases though. Okay. One sec, I will come back. Just gotta do something real quick. But what I'm gonna do next is I'm actually gonna redo this whole solution from scratch, and we're going to try it another way, recursively, using a similar approach, going to the left subtree and then just checking left and right node until we hit the end, and just traversing the right subtree, checking left and right node until we hit the end, and it should all match. So yeah, let's try that. I'll be back.